Because some of the concepts, few of them or a lot of them I write down. Some of them I just speak. Okay? So it asks you to pay attention, to listen, and in case you have a question, I'll be happy to see. So if you do this homework, at least now you have 6 examples of general block quality diagram. It's not enough, but you have to advance it as well as you can. Okay? So I would like to thank God who have given me a chance to teach you. This is Olenjolai, a citizen of the kingdom of heaven and a citizen of beautiful country called Tanzania. Welcome in the next lecture, lecture 4. I hope to see you and I hope to feed your mind in order to be transformed from ignorance in electronics drawings to mastering electronics. Say AC, high power. AC, high power. DC, high power. DC, high power. For instance, in inverters, sometimes we might be dealing with DC high power of 339 volt. Can you imagine about 12 DC, it means a DC power of 12 volt. Then do you think about the 339 volt DC or DC voltage? So one of the advantages of Igbt, we used to control and convert high electric power. Say high electric power. High electric power. Very good. Again say high, say controlling high electric power system. Controlling high electric power system. So examples of this system, examples of high electric power system. Happy New Year 2025. I would like to take this opportunity to wish a Happy New Year to my physical students who are pursuing Bachelor in Engineering or Bachelor in Electronics and Telecommunication Engineering at the Dar-es-Salaam Institute of Technology. Happy New Year, my students. Happy New Year. Thank you. Happy New Year also online community from different institutions, from different colleges, students, and even professionals from different industries, from different universities. My name is Olenjolai. The first time to meet me, I would like to take this opportunity to welcome you into our one online college and also our one online institutions of technology. Our online institutions of technology or institution is called the Tanzania Online Institute of Technology. It's actually one of the institutions where we are training we are creating our contents according to the curriculum of the third education, which we call tertiary education in Tanzania. And then we have another online college that's called the Tanzania Online Full Technical College. In these two, it means in Tanzania Online Full Technical College, we are teaching fundamental concepts, especially for the ordinary diploma students. And then in Tanzania Online Institute of Technology, we are teaching undergraduate or bachelor degree students. However, that sometimes some of the concepts may be cross-cutting, because we have also some students who are pursuing a bachelor in electronics engineering or electrical engineering or computer engineering who have a background of science and mathematics. So it's better for them to build up the concept where we call them general year students or first year or freshman students. I have prepared a very important and clear and detailed fundamental, intermediates, and even detailed concept about electronics engineering. In the departments of electronics engineering, we have one of the modules that called the power electronics. We have a number of them. So we are teaching instrumentation and measurement. We are teaching electronics communication, laboratory departments of telecommunication. We are teaching electronics product fabrication. So we have a number of modules that we are trying to teach our students to build up the concept. But one of the modules is called the power electronics. And we are in chapter 2 in this module. That's called the power electronics devices. And then this is lecture 3. Brief descriptions of power electronics devices. I have some physical students. What are the requirements in this class? Fresh mindset, concentrate, it's a serious class, write down, ask a question, listen, write, enjoy, and be happy all the time from the beginnings of the lecture to the end. However, this information will be actual, or we'll just discuss them, because that's what we call a brief description. It means we are going to describe, to give you a brief descriptions about different power electronics devices. And then in the next 6 chapters, we'll be discussing one power electronics device in detail. So if that's the case, I'm ready to teach you. I don't know about these physical students who are in this class. Are you ready for lecture 3? Yes. Class, are you ready for lecture 3? Yes. So if you are ready for lecture 3, let you remind us what did we discuss in lecture 2. So quick review of lecture 2. So in lecture 2, the title still the same with lecture 3. The title of the lecture was what? Brief what? A brief descriptions of what? Power electronics devices. Say power electronics devices. Yes. And in lecture 1, we mentioned the 10 examples of power electronics devices. Can you remind us? The first one, a general purpose diode. Right? Yes. Or we call it rectified. We simply call it diode. Okay? But general purpose diode. Okay? The second one, varactor diode. That's a special one of the example of the special purpose diode. The third one, power bipolar junction transistor. Then, or power BJT transistor. The fourth one, a Mosfet. The fifth one, the fifth one is called the thyristor, or silicon controlled rectifier. Then another one is called what? Insulated gate bipolar junction, or IGBT. Bipolar transistor, not bipolar junction. It's called insulated gate bipolar transistor, or IGBT. Another example, talk to your neighbor. First of all, greet your neighbor. Good afternoon, my neighbor. Greet again your neighbor on your right hand side. Say, good afternoon, my neighbor. And then while you are touching him, and give him or her a fresh smile for the 2025. So simply, we mentioned that we have general purpose diodes. General purpose diodes. We have, that's the first power electronics device. The second one is, we say that varactor diode. Varactor diode, say varactor diode. The third one is called the power bipolar junction transistor. Power bipolar junction transistor. The first one is called the metal oxide semiconductor field effective transistors. Then the fifth one, we say that we have what? Silicon controlled rectifiers. Then number 6, we say that you can have thyristors. Thyristors. Then number 7, we have also another one, which we call it these thyristors. We say that we have insulated the Igbt bipolar transistor. Then number 8, we say that we have also what? Silicon SSR. Silicon what? Solid state relay. Then number 9, we said what? GTO. Gate turn off thyristor. So you have GTOs. Number 10 is what? Power capacitor. And the power what? Inductors. Power capacitors and power inductors. In lecture 3, or in lecture 2, we discussed about general purpose diode. We say that we have 2 types of general purpose diode. The first one is a PN junction. Say PN junction. PN junction what? Diode. And I gave you some examples. And the second one is called what? Rectifier. Say rectifier. But this is a rectifier diode because also you have silicon controlled rectifier. So you have 2 types of rectifier. We have a general purpose rectifier and you have silicon controlled what? Bear in your mind. Get to open your mind. So this is a general purpose rectifier diode. Then we say that rectifier is the one that we are using in power electronics, where that we have 3 types of rectifier, and you define what the means of rectifier. Okay? Then the first one is called the half-wave rectifier. Say half-wave rectifier. And the second one is called the full-wave rectifier. Say full-wave rectifier. And the third one is called the bridge rectifier. We discussed about this concept, and also we discussed in the simulation, and we are heading to the hardware implementation. And then we say that this rectifier is actual response to we are using rectifier in power electronics to convert DC, to convert AC or alternating current power into DC. Into what? DC. That's what we have discussed. Then I left you the homework. And this homework I asked you in test 1. Explain briefly how varactor diode is used in power electronics. For those who have done it, they got something to write. For those who did not do the homework, or let's say I'm very sorry, because you had the question in your hand. Okay, so today, and then we discussed about the power bipolar junction transistor. We said that before discovery of Mosfets and Igbt, power bipolar or bipolar junction transistors have been used in power electronics. But after discoverings of the Mosfets and the insulated Igbt bipolar transistors, then Mosfet and Igbt replaced the bipolar junction transistor in power electronics. That's what we discussed. Okay? However, that we are using power bipolar junction transistors in case of amplifying power electric signal. We say that we don't have that intensive use in case of the power electronics, not in amplifying power electrical signal, because you have power electronics and power electric signal. So when you discuss about power amplifiers, we are using bipolar junction transistors. We are using field effect transistors. But for that context, we don't categorize it as the power electronics. Why? From the definition of power electronics, we say that power electronics, what is power electronics? Is a branch of what? Electronics, which deals with what? Conversion, conditioning, managing, and controlling what? Electric signal by using semiconductor devices. So today, let us discuss about MOSFET. So this is number 4. So our discussion, in case you missed lecture 2, access it in Tanzania Online Institute of Technology. The playlist is called the Power Electronics. So today, ladies and gentlemen, let us discuss about the metal oxide semiconductor field effect. Field effect transistor. Let us have brief discussion. Transistor. This in short we call it Mosfet. So our main focus, we are not going to discuss about what is Mosfet. We are going to discuss that how a Mosfet is used in power electronics. Class A metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor. Okay. So he said that the main, one of the main function of Mosfet or metal oxide semiconductor field effect transistor, Mosfet, one of the main functions of the Mosfet in electronics engineering, is used as a high speed transistors, or is used as a high speed transistor to control, or that control the flow of electric current, between its two terminals. And these two terminals are called the drain and the source. Hello? Sugarman, what's going on? So one of the main functions of the Mosfet electronics engineering is usually as high-speed transistor. Say high-speed transistor. What is the main functions, or why do we need this high-speed transistor in electronics engineering? We need it to control the flow of electric current between its two terminals, drain and the source. Metal oxide semiconductor field effect transistors, they have three terminals. The first one is called the gate, the second one is called the drain, the third one is called the source. Say gate, say gate, drain, source. So gate corresponding to the base in bipolar junction transistor. Source corresponding with emitter in bipolar junction transistor. And the drain corresponding with collector in case of the bipolar junction transistor. So the main one of the main functions of the Mosfet in electronics engineering generally, and this main function we are using it in power electronics, is we are using these transistors as a high-speed switch. Means high-speed transistor. High-speed, I think that I left something. High-speed switches. High-speed transistor switches. So, write this one. So, high-speed transistor switches that control the flow of electric current between these two terminals, drain and the source. Say drain and source. Say drain and source. Your computer or your laptop, it consists of billions number of Mosfet. Your computer, the main part of your computer, or the main part of your mobile phone, or the main part of your flat screen television receiver, or the main parts of the printer, or the main parts of supercomputers, server computers, etc. is just the switches. That's the main part. So we have billions number of the switches. If you say that the speed of this computer is 3 gigahertz. 3 what? 3 what? Gigahertz. Mean that that transistor contains billions number of the transistors. When you say that the speed of this transistor, the speed of this computer is 10 gigahertz. So what the difference is from other computers? The number of Mosfet transistors. Are we together? Yes. You like your speed, yeah? In case we say that we have 5G, yes, we are heading to the 60G in case of telecommunication. It means we are discussing about high speed. So whenever we are discussing about high speed in digital technology, think about the increment or the increase or the large number of the Mosfet transistors. Happy New Year. Then, remember that we are not discussing about field dioxide semiconductor. I used to teach a metal oxide semiconductor field effect transistor. It's a topic that I can teach even 20 lectures, theoretical. Yes. And simulation 10 simulation circuit. And practically we may do even maximum 8. So then at least there you can say, okay, I understood the MOSFET. So total is what? 20 plus 10? 30, right? 30 plus 8? 38. Minimum. Ask your neighbor. How far have you gone with MOSFET? Ask your neighbor. Ask your neighbor, how far have you gone with MOSFET? Ladies and gentlemen, this is all about electronics nowadays. This is modern electronics. MOSFET, it's all about modern electronics. You say, I want one day to design my own mobile phone. If you're ignorant in MOSFET, my friend, I tell you that you will die with that vision. Or you may induce it to your next generation. My children, you know me, your father or your mother. I had a vision. I had a vision to design and make a new mobile phone. Unfortunately, I failed because of various reasons, including financial, including theories, Vitini, including so many reasons. So I ask you to fulfill it. And then your children will say, no, Father, thank you very much for sharing. No, but we are .com generation. We have our own vision. Okay, we'll pay for your own vision. Okay, bye-bye. Then, what the application or how we are using MOSFET in power electronics. That's our main focus. So simply, we say that power electronics application. Class A MOSFET. I can say MOSFET. Yes, I have a course called the Intermediate Practical Electronics. Because MOSFET is not fundamental, it's a little bit advanced more than. For the fundamental is bipolar junction transistor. So we say that the power electronics applications of 40 of MOSFET. How are we using power electronics? How are we using MOSFET in power electronics? Well, this is the discussion. We say that MOSFET, class A MOSFET again. Say MOSFETs. So MOSFETs are widely used in widely used in switching application. Are widely used in switching applications for DC to DC converters. So we widely use the for widely use the in switching application, switching applications of power electronics power electronic circuits. So he said that MOSFETs are widely used in switching applications of power electronic circuits as follows. So we are using MOSFET in power electronic circuits of what? Number one, DC or direct current to direct current converters. Direct current to direct current converters, expect to see MOSFET. And the second application, we are using MOSFET in also in what? In DC to AC converters, which we call them inverters. Class A inverters. Say inverters. So we are using MOSFETs in design in DC to DC converters as one of the conversion, where we discuss about what? Step up the voltage and step down the voltage. That was question number 1A in a test. Step up voltage, step down what? Voltage. The questions in test 1 was about power electronics. That's why we asked you to differentiate power electronics terms, not electrical terms. So if you discuss about transformer, I'm very sorry. That is completely wrong. And I taught that concept, I did not write. I just taught, I just spoke. And I taught for 10 minutes. I was explaining in the same class. It was almost around 7 hours. Okay, so it is DC to DC. Say DC to DC converters. Say DC to DC converters. Also, you are using MOSFET in DC to AC converters. These are the power electronics conversion. But also, we are using MOSFET in power electronics to design motor control. Motor controllers. Motor controllers or motor drivers. And why do we use them? Or why do we use MOSFET in this circuit? Within these circuits, there are some parts. Listen. Within DC to DC converter system, and DC to AC converter system and motor controllers, there are some parts or subsystems of this system need high speed of switching. It needs the high speed of switching electrical signal and a special voltage. Student, I'm not going to write what I'm saying. Let me repeat. In DC to DC converters, in DC to AC converters or inverters, in motor controllers in design or in their system, there are some subsystems that need high speed of switching. And that high speed of switching of electric signal, which in terms of pulses, can effectively perform this by MOSFET rather than any other semiconductor device. So, MOSFETs are used in those three power electronics system because of its high speed. Because of its high speed, because of their fast switching speed and the efficient So we are using MOSFETs in DC to DC converter, in DC to AC converter, in motor controllers or motor drivers because they have a fuzzy switching speed rather than other power electronics devices, and also they are most efficient rather than other power electronics system. Hello, Mr. Yellow? Stand up. Jonas, stand up. Stand up, please. So this is the brief discussions of Mosfet in power electronics. Okay? Previously we mentioned. Now we have a brief description. Okay? Is it clear? Is it clear? Is it clear? Yes. Well, number 5. Let us discuss briefly the use of thyristors in power electronics, and especially we'll be focusing in silicon control D rectifier. Silicon control D rectifiers, or SCCR. So one of the main function of class A thyristors, say loudly thyristor. So one of the main function of thyristor, is a semiconductor. This is the semiconductor device. So this is the semiconductor device that acts as a switch. So it's acting as a switch, turning on. So its characteristics, it can act as a switch, turning on when triggered. When triggered, and staying on until the current is reduced below a certain threshold. Below a certain threshold. So the keywords in this main function of thyristors, we say that the main function of thyristor in electronics, engineering, general, one of the main functions in electronics engineering is usually is a semiconductor device that acts as a switch, and it will turn on when it is triggered by another system or another electrical signal. And also its characteristics can staying on, operating. Listen and look. So one of the main functions of the thyristors in electronics, it can act as a switch. Say act as a switch. Remember, Mosfet also can act as a switch. Remember, bipolar junction transistor also can act as a switch. Remember, insulated gate bipolar transistor can act as a switch. We have so many electronics switches. But one of the peculiar characteristics of the thyristors, especially silicon controlled rectifier, we say that it can act as a switch, turning on when it is triggered. Say triggered. We have triggering or triggered signal, especially in electronics, for instance in 5/5 timer. When it is triggered and staying on until the electrical current or the current is reduced below a threshold or a certain threshold. What does it mean? We say that, for instance, we have a silicon controlled resistor, silicon controlled rectifier. Then we say that the assumed has been triggered to switch on or to turn on. Because when you say that it can act as an electronic switch, it means it can turn on and turn off. So one of the characteristics, peculiar characteristics of the thyristor, it can turn on when it is triggered by another external signal from another electronic circuit, and it is staying on until the current has been reduced between a certain threshold. For instance, let's say that triggering current, which is the C, let's say that the triggering current is 20 milliampere. So when that is a silicon controlled rectifier or thyristor is triggered by 20 milliampere, it can turn on. And when the triggering current is not reduced, and suppose that maybe the threshold current, say threshold current, so the threshold current, suppose that the threshold current is 2 milliampere. So when a thyristor or silicon controlled rectifier, Amani, is triggered by triggering current of 20 milliampere, then the triggering current is not reduced. So the thyristor or silicon controlled rectifier will remain what? On until the triggered current is reduced to a certain threshold or to a certain amount. Suppose that the triggered current is reduced from 20 milliampere to 1 milliampere. Then for that case, the thyristor or the silicon controlled rectifier will turn off. And we say, why are we discussing that main function, one of the main function? Because that the function the function that performed by thyristor or silicon controlled rectifier make itself to be used in power electronics. However, that function might be applied in other field of electronics, but one of the field is power electronics. Okay? Okay, Juliet? Class, is it clear? Eh? Then the question is, well, if thyristor or silicon controlled rectifier has these peculiar characteristics, then how do we use it in power electronics? So now we say that power electronics application of thyristor. Power electronics application of thyristor. Power electronics application of thyristor or silicon controlled rectifier. How are we using it in power electronics? And I think that I forgot here to give you examples. Are these examples of Mosfet? Mosfet used in power electronics. PE, power electronics. The first one, we are using N-channel Mosfet. We are using N-channel Mosfet in power electronics, but also we are using P channel. Class A, N-channel Mosfet. Say it loudly, N-channel Mosfet. Say P-channel Mosfet. Those are the examples of 40 of MOSFET. So he said that thyristors, a special silicon controlled rectifiers, are used in power electronics to control AC power. So he said that thyristors or silicon control rectifier are used in power electronics to control AC power. Class A, control AC power. Control AC power. Say it again. Control AC power. Again. Control AC power. So example of this AC power system. Examples of AC power control system in power electronics. We use thyristors or silicon controlled rectifier as power electronics device in light dimmers. Say light dimmers. Again. Do you know them? Ask your neighbor. Do you know light dimmer or light dimmer? Wait the response. The answer is yes or no? Blue? Light dimmer is blue. What the means of dimmer or dimmer? What the origins of the word dimmer or dimmer? It's come from the word dim. What the means of the word dim in Swahili? Kufifia in Swahili. So light dimmer means what? But in AC. Have you ever seen? I think that I can give you a good example. You can have a AC lamp which you can set, or you can increase and reduce the amount of light given out. Have you ever seen it? Kuna taa za umeme ambazo unaweza ukaongeza mwanga au ukapunguza mwanga. Unazifahamu hata kwenye movie, hujawahi kuziona? Sababu wendo akasema baba hana na mama hana kwenye movie, au movie ni uongo, si ndio? So this is the one of the AC power control system that we need to use thyristors. But also we use silicon control rectifier thyristors in motor control, motor speed control. Say motor speed control. Say motor speed control. So when you talk about motor speed control, stop writing. It's very simple to experience this at the Dar es Salaam Institute of Technology. Where can you experience it? I said stop writing. You can experience it in escalators or in electric lift. Do you know electric lift? And it's very simple. Just to illustrate to you. For instance, electric lift is in ground floor. Then if you, for instance, you make a decision or you send a command that I want to go to the first floor, I want you to tell me to compare the speed of the lift. Then another state, a lift is in ground floor, and the first request has been sent into the lift is the destination is floor number 10. So for this case, the lift or the car, we call it after the cage, we call it the cage or the car, Amani, the car or the lift car or the lift cage, is traveling from ground floor to the first floor. For this case, the electric lift is traveling from ground floor to floor number 10 or the 10th floor. Okay, tell me the speed of the lift. Will the speed of the lift from G or ground floor to first floor equal is the speed of the lift from ground floor to the 10th floor? Eh? Will the speed be the same? Okay, so I was giving you an example that practically the speed of the lift from ground floor to the first floor is not equal to the speed of the lift from the ground floor to the 10th floor. Why? Because of motor speed control. So when you are pressing a button written number 1, then the controller will send or will control the speed of the motor because the distance between the ground floor and first floor is short. When you send the signal to the control brains or to the brains of the lift, which is microprocessor, and that microprocessor is integrated in PLC, programmable logic controller. So when the information has been sent that, okay, now the lift has to move to the 10th floor, then the brains know the distance between the ground floor and the 10th floor. So the signal will be sent to the thyristor in order to increase the speed of the motor of the lift. Why? Because there is a great distance that the lift has to move. Then I leave you a challenge. Will the speed of the lift will the speed of the lift when it's moving from ground floor to the 10th floor be less or equal or greater than the speed of the lift from the 10th floor to the ground floor? And if the answer is yes or any choice, whether it's greater than or less than or equal, state the reason. Okay, so that's the second applications of what of say thyristors. Say thyristors. So you can notice that we are using thyristors in electric lift. But also we are using thyristors or thyristors in phase control application. Say phase control application. Say phase control application. Class A phase control application. Say phase control application. In high power, say high power. In Tanzania, we have a high power company that's called TANESCO. So at TANESCO, we have two types of phase of electric power. We have one phase or single phase and three phase. So the thyristors or silicon controlled rectifiers may be used to control the phase. In case that you want to change from the single phase to three phase, or you want maybe the line to change from the three phase to the single phase. Question about rectifier or thyristors, brief description. Is there any question? First of all, is it clear? Is it clear? Is it clear? Some of you have sat like you are mooning. Say mooning. Say mooning. Yani baadhi yenu mmekaa kama mnaomboleza. Wakati ni mwaka mpya, mambo mapya, mawazo mapya, nguvu mpya, umetoka kusherehekea. Lakini baada ya sherehe, hela huna, umechoka, umeboreka na leo ni tarehe 2 tu ya mwezi wa kwanza. Mwanangu, unatakiwa utembee mpaka tarehe 31 mwezi wa 12 ndio mwaka unaisha. Inawezekana ukaa uko hoi. Okay? Okay class? Is it clear? Yes. Question about what you have discussed? Number 6. Say number 6. The 6th example, the 6 brief descriptions of 40. So brief descriptions of insulated gate bipolar transistor. So brief description. Brief description of insulated gate. So insulated gate bipolar transistor. Bipolar transistor. In short, we call it Igbt. Okay, so we have to discuss about brief descriptions of insulated gate bipolar transistor. Say insulated gate bipolar transistor. Say it 3 times. 1, 2, 3, go.
Insulated gate bipolar transistor.
Again.
Insulated gate bipolar transistor.
Again.
Insulated gate bipolar transistor.
Ladies, yourself, say 3 times. 1, 2, 3, go. Sure, that's the voice of the ladies. Ladies first. Second time. Third time. Some of the ladies in this class, they pretend as though gentlemen. Gentlemen, 1, 2, 3, go. Including Zara. Again, second time. Again, third time. All the students. Ladies are silent, including ladies. Second time. Third time. Well, so we say that. Let me give you a brief description because you do not discuss. You haven't learned about this. So he said the insulated gate. The insulated gate bipolar transistor. The insulated gate bipolar transistor Igbt is a hybrid semiconductor device that consists Mosfet, Mosfet for controlling is BJT's high current carrying capacitor. Okay, consists in Mosfet for controlling electric signal and the BJT BJTs, high current, carrying capacity. So separating, or let me just write another sentence, then I'll discuss together. So you say that the insulated gate bipolar transistors are, okay, BJTs, acting as the high speed and the efficient electronic switch. Separating. Listen and look on the blackboard. Tell your neighbor separating. Tell your neighbor whether he or she is happy or unhappy. Separating. Then tell your neighbor, listen and look on the blackboard. I told you to talk to your neighbor. Well, so this is the brief descriptions of insulated gate bipolar transistor or IGBT. We say that the insulated gate bipolar transistor or IGBT is a hybrid. Say hybrid. I think that the first time when they've been introducing the word hybrid is in biology. Right? So hybrids is actual combinations of more than one thing. So we say that this is a hybrid semiconductor device that consists of two semiconductors, Mosfet and the bipolar junction transistor. Hello, can you stand up please? Stand up. So it consists of how many devices? The first one is what? The first one is what? The second device, semiconductor device, is what? A BJT. We discussed about power, BJT. I discussed about Mosfet. So this is the integrated. So it's integrating Mosfet and the bipolar junction transistor. Maybe you are shallow in BJT, you are shallow in Mosfet. I want to tell you in advance, you'll be intensively shallow in IGBT because you need the knowledge of Mosfet and the knowledge of BJT to understand the IGBT. Insulated gate. Gate is the one terminal of Mosfet. Right? And then bipolar transistor, this is BJT. So it's integrations of Mosfet and the bipolar junction transistor. But the Mosfet for that case, will be used to control electric signal, while the BJT will be used as the high current carrying capacitor. So the gate will be insulated, and then the gate of Mosfet will be insulated, but the bipolar junction transistor will be used to process the high current from another circuit. But again, we say that the IGBT, insulated gate bipolar transistor, acting as a high speed, say high speed, say high speed. Where did it get the high speed? From Mosfet. And the most efficient electronic switch. Remember that bipolar junction transistors are not high speed electronic switches, but field effect transistors are high speed electronic switches. Okay? So you have to broaden your knowledge of electronics. So we are going to discuss now how are we using the IGBT in power electronics. So you can write. Right. About, we are still going to use brief descriptions of the insulated gate bipolar transistor. It's because of the time, but I think if not, we are rushing for time, I could even prepare 3 to 4 lectures to teach you about this, because I know you'll just have vested the knowledge of IGBT in power electronics itself. If you miss it there, I don't think you'll meet it. But Mosfet, you'll encounter it. Bipolar junction, you'll encounter it. What capacitors, you'll encounter it. All the 4 years of your education. Just inductors, you'll encounter them, because you cannot discuss about RF transmitter or RF receiver without inductor. Okay, so now let us have a brief discussion of 40 power electronics application of IGBT. This is the answer of the question that how are we applying IGBT in power electronics? Or where do we apply IGBT in OT? IGBT, I forgot again examples. Sorry, these examples. Examples of thyristors. Say examples of thyristors. Say examples of thyristors. So the first example of thyristor is called the silicon controlled rectifier. Say silicon controlled rectifier. The second example of thyristor is called the triac. Say triac. Say triac. Say triac. Listen your neighbor. Say triac. Your neighbor is say what? Triac. Triac. Asida? Say triac. Okay, if you don't pronounce, you leave it there. Then another example is called the diac. Say diac. Say diac. Tell your neighbor, that is power electronics. So you have SCR, we have triac, diac. Say SCR, triac, diac. 1, 3, go. So the IGBTs are used in power electronics, in power electronics to control and convey the high power. The high power or the high electric power. So another advantage of this one is used the IGBT are used in power electronics to control high power. Say control high power. Say to control high power. Say AC high power. DC high power. For instance, in inverters, sometimes we might be dealing with DC high power of 339 volt. Can you imagine about 12 DC at Mr. DC power of 12 volt? Then do you think about 339 volt DC or DC voltage? So one of the advantages of IGBT, we used to control and convey it high electric power. Say high electric power. Very good. Again, say high, say controlling high electric power system. So examples of this system, examples of high electric power system. AC converters. Say DC to AC converters. But remember that this is high DC to AC converter system. The second example of applications of power of IGBT, we are using them in motor drivers or motor drivers. Say motor drivers. Say motor drivers. For the current amplifications or amplifying currents, motor drivers. We said we have three types of motors, main three types of motor. We have DC motor, we have stepper motor, we have servo motor. And whenever we talk about motor, we talk about output. Say motor drivers. Then the third example of the system where that we are using the IGBT is called the high voltage. Say high voltage. High voltage DC transmission. High voltage DC transmission system. High voltage DC transmission system. Say high voltage DC transmission system. So this is another applications where we can use the IGBT, insulated gate bipolar transistor. Any questions about what we've discussed or any questions about IGBT? Let me know in case that you have a question about IGBT according to the brief discussion that we have discussed. However, that I leave it to you a challenge. You have to make sure that you go in detail about the use of IGBT in power electronics. Okay, class? Are we together? Do you have a question? You have a question? So we have discussed how many power electronics devices? Not in total, in lecture 3. 3. The first one? The second one? The third one? Yeah, so God is saying or is telling it's enough for today. Go and dig in detail. But let me leave you the homework, because any teacher who loves his or her students will always leave a homework to students. A homework. So this is homework for lecture 3. So the homework, just I leave you to you one question with different part. In this one, briefly describe the use of the following power electronics devices in power electronics. So the first one is IGTO or GTO. Say GTO. Get an 40. Get an 40 class. Also, triac. And number 3, power capacitors. So this is your homework. Class, is the concept clear? Is the concept clear, class? Well, so that's the end of lecture 3. I would like to welcome you in lecture 4, where that we are going to discuss about we are going to have a discussion about brief descriptions of other power electronics devices. So total we discussed these 6. We have a number of power electronics devices, but we have to discuss few of them. Make sure that you do, because if you do this homework, it will be the prerequisite for lecture 4. Are we together? So I would like to take this opportunity to thank God who have given me a chance to teach you. And I would like to take this opportunity to thank you who have joined with me in this fantastic lecture 3 of power electronics devices. But let me take this opportunity to welcome you in lecture 4, where that we are going to learn about brief description concerning about other power electronics devices. I want to give you a promise. In case you'll be a serious physical and online students on power electronics, and you'll be learning this concept from the class, and after the class you go deeper. I want to tell you that within 6 months or 1 year, you'll be building a very interesting power electronic system to solve real life problems. The only important salary that you have to pay power electronics is just the time, right? Because you can build it, the interesting power electronic system, by just using the computer, or by just using the online electronic simulation software, where actually you can access them by using your mobile device. So it's not the matter of having a computer. You can have your smartphone or your iPhone and build a very interesting and testing, different power electronic system that can be implemented to solve real world problems. So it's not the matter of financial status of the area where you are. You have the internet, you can access a lot of materials. The matter is time. Are you ready to dedicate your time for the power electronics? That's the big question. And it's your decision. You may dedicate your time or you may not. And the results are known. If you dedicate your time, you'll be different. And if you don't dedicate your time, you'll be power electronics politician. Say power electronics politician. You'll be just speaking power electronic system, but if you've been given everything, you cannot implement. Okay, so have you understood? Yes. Always I appreciate my students if they have done a work, because what is work? What is work? Define work. Work is? Is ability. Work is the ability of doing work. What is work? Pardon? Resistance? Okay, you say that the lecture is ended. So, sir, don't ask me more questions. Well, so let us get prepared. We are going to have 6 claps for you, special for the 2025. 1, 2, 3, go. Hongera. Imara. Wow. Beta. No. Goody. Beta. Bessie. Thank you very much. May God bless you. See you in lecture 4. Bye-bye.
Africa.